We have curves and we have to find the area bounded by this curve. So let's draw first xy plane. We have curves x equals 1 and x equals 3. So let's first find this 1, 2, 3. So this is our x equals 1. And this is our x equals 3. Next, I will have to draw the graph of y equals e to power 1 over 2x. So we know that this is exponential function. This graph is in the first and in the second quadrant. For 0, we will have e to power 0 is 1 value. For x equals 1, we will have e to power 1/2. So let's calculate this. E to power 1/2, this is equal 1.64. So approximately will be here. And for 3, we will have e to power 3 over 2. This is 4.48. So this value is 2, 3, 4. So this point will be approximately here. Our graph e to power 1/2 x is going to positive infinity. This is y equals e to power 1/2 x. Next, we have function y equals -1 over x. This is hyperbola. Hyperbola is, because has negative sign, is in the second and in the fourth quadrant. But because we have x equals 1 and x equals 3 in the first and in the fourth quadrant, so we don't need to draw the graph of hyperbola in the second quadrant, only in the fourth. For x equals 1, we will have -1 value. And for x equals 3, will be -1/3. For 1/3, we will have value -3. Something like this. This is our hyperbola. Is going to, when we are close to 0, we are going to negative infinity. When x going to infinity, the value going to 0, but never past 0. So value 0. So we got our area between these 4 curves. This is our area. We can shade this. This is our area which we need to calculate. This area is between interval from 1 to 3. The curve which is upper is e to power 1/2 x. This is our upper function. And the lower function is y equals -1 over x. So we have our area is equal integral from 1 to 3 from upper function, so e to power 1/2 x, we have to subtract the lower function, so this is -1 over x with respect to x. This is equal. We have integral from 1 to 3 of e to power 1/2 x, negative and negative give us positive 1 over x dx. To solve first integral, we will use substitution method. Let's put that 1 over 2x is equal u. So 1/2 dx is equal du. We need dx, so I will multiply both sides by 2. So dx is equal to du. So our integral we can rewrite to sum of two integrals. From 1 to 3 will be e to power 1/2 x dx plus integral of 1 over x from 1 to 3 dx. So this is equal. First integral will be from 1 to 3 we will have e to power u, and we have 2 du. 2 we can put before integral symbol du, plus integral of 1 over x is natural logarithm of absolute value of x. But because we have here x from 1 to 3 interval, so this is positive values, we don't need absolute value. We have only x. And integration limits from 1 to 3. So this is equal. We have 2. Integral of e to power u is e to power u. And we will come back to our substitution because I didn't change integration limits. So we have e to power 1 over 2x. And the limits we have from 1 to 3. Plus, and we have natural logarithm of x, limits from 1 to 3. So this is equal. First we have to plug upper limits, so it will be 2 times e to power 1/2 times 3, so it's 3 over 2. And we have to subtract the lower limit, so it will be minus, I can put this in parentheses, e to power 1/2 times 1 is 1/2 plus, and we have now natural logarithm of 3 minus natural logarithm of 1. So this is equal. I just plug upper limit and the lower limit to natural logarithm of x. So this is equal to times e to power 3 over 2, and we can multiply by 2, so it will be minus 2e to power 1/2 plus natural logarithm of 3, because natural logarithm of 1 is 0, so we don't have to write. This is my solution. Of course, we have to add square units because this is area. This is my solution.